Thank you.
Thanks a lot. So it's a pleasure for me to be here, and I would like to thank the Noviwam Conference Committee for having me cross the Pyrenees and overcome the difficult weather situation that we have in France. So I'm going to discuss the different ways we economists consider trying to narrow the gap between water supply or water availability, if you want, and water demand or water use. So here, I'm only discussing the quantitative aspects, not the qualitative aspect of water management. You have seen on the previous slides, previous presentations, in fact, different maps and charts with colors indicating various levels of water scarcity. And we resource economists are essentially paid for trying to modify the color on those maps and charts. One of the conclusion remarks by José was that one thing that we should consider is to move from the paradigm of trying to increase the water availability to trying to modify the water demand. So when we economists are discussing ways of trying to find efficient or optimal strategies for trying to narrow the gap between water availability on the one hand and water use on the other, what we typically also want to do is try to find what's the best policy, perhaps which may perhaps not be only on the supply or demand side. Okay, so one thing that we need to do is to explore one policy after the other, try to look at its relative efficiency and its social acceptability, and in the end, provide decision makers with information regarding the advantages and the drawback of each policy option. So here, I've spent decades working at the very individual or micro level, trying to understand the way economic agents like residential users, industries, and farmers were modifying their behavior when faced with economic instruments such as subsidies, tariffs, and quotas. And now, perhaps because my eyesight is not as it used to be, I now prefer to look at bigger pictures and look at what's happening really at the regional or the state level, and trying to compare the demand side management policies, that is, what kind of economic instruments should we use to try to modify the individual behavior of agents who typically use water for their consumption or production purposes. We also can consider supply management policies, such as the ones which are typically either market or non-market policies. So you have the list there. The tariffs and the subsidies are fairly popular. While the subsidies are fairly popular for the farmers, perhaps the tariffs are less popular there. And there are also other collective policies that have been very much debated upon, like the voluntary agreements. Okay, so all those policies, in fact, have in common that they are really designed for trying to solve local issues. Okay, we have a issue with water scarcity on a given watershed. We need to solve this problem with local instruments. Now, the problem I would like to point out at this stage is that we should not forget that when we are looking at a particular region, this particular region is not disconnected from the world economy. It's exporting goods, importing goods, and the goods in themselves also have some level, some content of water, because water was used in its production. Okay, so through international trade, we have massive volumes of water traveling around. Okay, so what I want to do with this presentation is to give some insights about the way we can think when we are discussing what are the best policies in terms of demand management or supply management, not to overcome the fact that there is some international trade happening between different regions. Okay, so when we first have a look at the demand side policies, one of the most popular one for us economists is to look at prices. Okay, we want to identify what's the expected behavior of users when we modify the price of the resource. So here you have the some fairly recent results in terms of the estimation of the sensitivity of households when we modify the price of drinking water. So for various countries like France, Spain, and Italy, what we almost always found is a sensitivity which is not very large, but at least it's there. It's something like minus 0.2, okay? Which means that when you increase the unit price of water by 1%, average water consumption goes down by 0.2%, okay? There are also other options that we can think of in terms of information, dissemination of information regarding water scarcity, and also rationing or restriction policies. Okay, so here you have two examples. The first, the left-hand panel is a information campaign in the US saying that water is dumb. If you water grass, grass is dumb. If you water grass 2 minutes less every day, grass wouldn't notice. Okay, so you should try to spare a bit of water. And on the right-hand side, you have a heavily subsidized low-flow equipment for your bathroom. Okay, in terms of policy impacts, those kind of campaigns have a limited impact. In many cases, it's less than what the price policy would be. What's interesting is to notice that, of course, the rationing or the restriction policies have a major impact, far more, in fact, than the information one. And the interesting aspect is to see at what's happening, in fact, when we are combining the price policy together with restriction or rationing. So this was for the demand side. Now, when we turn to the supply side, essentially, the major problems with trying to cope with water scarcity is the fact that the water scarcity is due to seasonal patterns, the major users happening in months in which we don't have enough water there. Okay, so we need to cope with this both temporal and spatial heterogeneity in demand and supply. So the obvious way is to try to find ways of increasing water availability. Okay, so we can try to produce fresh water, and in particular by using the seawater or the grey water desalinization, which we may want also to recycle wastewater or to restore the groundwater quality. So that's the second possibility, the second category of policy options. And the third one is to try to find water from elsewhere. And this elsewhere being provided by all the countries around you, which may be associated with larger volumes of available water. And those volumes could be, in some sense, transferred to your own country when you are importing goods from those countries. Okay. So in terms of supply side policies, we can think of the desalinization policy. So here you have some examples of countries having massively invested in desalinization plant capacities. The interesting aspect is to look at the last column, in which you have the average number of cubic meters per head per day. And you can see that some countries like the United Arab Emirates, they have more than 1 cubic meter produced by desalinization plants per day. Okay, so it's really, there is a strong strategy there compared to countries like, if you look at Australia, the interesting thing is to compare the the production capacity in place in 2009 with the projected one at the end of 2013. It's more than twice, well, it's slightly less than twice the volume, with more than 2 million cubic meters being produced there every day. Okay. So we have the demand side options, we have the supply side option. Now the question for us is to wonder whether it's always more interesting to focus on the supply side policy or the demand side. Okay. In most cases, this is not an issue. It's clear that because of technical or even costs-related considerations, it's always easy to choose either a demand or a supply side option. Okay? There are some cases, however, in which the choice is not so clear. Here I've produced an example from Algeria, in which they have decided to go for a massive policy of desalinization in 2002 with an objective of 2.2 million cubic meters per day by the year 2030. And the question of this empirical work is to compare the policy of augmenting the supply side, the water availability, to compare with the demand side management, which would essentially consist of switching from conventional irrigation options to a more high-tech policy of drip irrigation. And in the table, you have on the left what's corresponding to the supply side, that is the desalinization option, and on the right, you have the demand side management. If you compare both, those authors have computed that the cost of producing more volumes from desalinization water, it costs about 0.66 euros per cubic meter compared to 0.08 euros per cubic meter when you are pushing for the demand side management. That is, when you are irrigating in a more efficient way. And when you compare both figures, you have a clear example of the advantage of going for a demand side management policy rather than the supply side one. Okay. Now let's turn to the virtual water concept, which is the basis of the presentation here. When we are talking about virtual water, it simply means that we don't see it, but it's contained in the goods that we produce or that we consume, and those goods that are traveling because of international trade. Okay? So we can compute, in principle, for every good which is traded between regions or across countries, we can compute some water footprint, which would be the equivalent of the ecological or the carbon footprint that we have. That we know. We can also distinguish between the blue water print, the green water, or the gray water, depending on the origin of the water which was used to produce those particular goods. Here you have an example of the virtual water in domestic goods. Okay, for 1 liter of beer, you are consuming 7 liters of water, and to produce 1 kilogram of meat, it's between 4,000 liters and 10,000. So I'm not saying that you should completely drop meat and switch to beer. I'm just saying that there is a very large difference across consumer goods when you look at the basic inputs which are being used there. Okay. You can also draw some maps to represent the virtual water balance between countries. Okay. In red, you have the countries which are net importers of virtual water, and in green, you have the net exporters. Okay. So what you can see essentially is that the developed countries from North America are basically exporting water to Asian or African or countries, which are essentially in red. Now, in the case of crops, things are slightly more easy and also more interesting because, as we have seen this morning, agriculture is the major abstraction sector in terms of ground and surface water, and it's also the most important actor in terms of net consumption. Okay, so we really would like to concentrate on agriculture and to compute virtual water content which would be devoted to crops. Okay, so for doing that, what we do is to divide the crop water requirement by cubic meter per hectare by the crop yield in ton per hectare, and we can compare those crop water footprints for different countries. Here I've taken the case of Mexico and France because my co-author is from Mexico. Okay, we can compare across countries and also across the origin of water, depending on whether it's a green water, blue or gray. Okay, so I'm going to skip this. We can also rank countries if we want. So here I have an example of ranking of countries in terms of water imports in billion cubic meter per year. So what you can see is that Japan and Germany are massive importers of water in terms of crop, whereas Argentina and the US are massive exporters. Okay, so the minus sign means you have a negative import, so you have an export. Okay, you are exporting goods which contain water. You can also look at a particular importing country and see what are the countries which are the most important ones in terms of goods which are exported to this particular country. Okay, so what's the footprint of the imported goods? So here I've taken the example of France, and in red you have all the major countries which are exporting goods to France and which are, for producing those goods, using significant volumes of gray, blue or green water. And you can even do a bit more. You can identify, in fact, the regions within those countries which are using water to produce goods which are going to be exported to France. And if you rank those, you can see that, well, here I've combined both countries which are exporting goods to France and also some regions in France, and I've ranked all those regions there. So what you can see is that, in fact, the most important region for us, for French people, is the Aral Sea region in Uzbekistan, representing more than 6% of water footprints, essentially due to cotton, okay, due to the textile. Followed by some French regions which you have there. Guadalquivir, here, it's about 2% of our total water footprints due to cotton, sunflower, rice, and sugar beet, okay? So that means that the region we are there is contributing to more than 2% of the total water which is contained in all the goods which French people typically consume. So literature, I'm going to skip all this section. The only thing I wanted to mention is that there's been a fast-growing literature on the economics of virtual water and water footprint. We now have several websites supplying us with indicators for ranking countries, computing net water imports, and so on. Unfortunately, the theoretical foundations and the empirical applications using this kind of indicators are quite rare now. There have been a couple of scientific articles by Hoekstra and Hung trying to match the water balance on the one hand and the water resources which were available in each exporting country. What they fail to acknowledge is the fact that virtual water should in principle be related to the origin of water being either green, blue, or gray in the exporting country, and also to the agricultural capacity of the exporting country. Okay, so this is what we try to do here by looking at the world picture with all available countries for which we had information on both the water resources, cropland, and export and imports. And if we compare, of course, some countries, we can see that there are huge differences in terms both of the availability of water, availability of cropland, and also the origin of water. If you just compare Malta here with 1.22 cubic meter per head compared to Iceland with more than 532,000, you see, of course, that there are major differences. So the interesting objective for us is to match those two. Okay, is a country with relatively more cropland, a relatively higher income level, is going on average to export more goods or to import more water-intensive goods? So that's the question we are asking there. So we have those groups of countries by geographical origin. Okay, so we have those 6 groups. And we also have group countries, not in terms of geography, but in terms of income level. So from the richest one to the poorest one. And it's interesting to compare by income group. You can see, in fact, that high income countries, OECD or non-OECD, are massively importing water, whereas low income or upper middle countries here are basically exporting water. Okay. So for the empirical application, we have used data from Aquastat, FAO-Stat, World Bank data. And we have essentially estimated this kind of model. That is, we explain the net virtual water import. That is the difference between the water which is imported in the goods minus the water which is exported. We try to explain this balance by the GDP of the country for a particular year, the import price index, that is goods that are relatively more expensive to import, and also some controls that you have here. And those controls are the volume of surface, groundwater, precipitation, and cropping land. 2 minutes. So I'm going to be fairly quick on results because they are very preliminary. They are not fascinating. The key result that we found is that when you try to explain the relationship between the net virtual water imports and the availability of ground or surface water for a particular country, it's not a good thing to combine all countries because they have fairly different production technologies, they have fairly different hydrological properties. It's better, in fact, to focus on different regions. And if we do this, we have slightly better results, which can be, in fact, summarized as follows. If we concentrate on the category which is, in fact, working best, and this is the lower middle income countries, in which we find that the higher the economic wealth, that is the GDP, the more this country is importing water through international trade. The more expensive imported goods, the less this country is importing. So this makes sense for an economist. And also the net virtual water import index is decreasing, and more so in both surface and ground water. So that makes sense. It means that if you are a water-rich country, you have a tendency of importing water less than a rich water-poor country. Okay, and of course there are severe data limitations that we are trying to cope for the moment. and we should consider other controls in the models that we are estimating, that is trying to control for energy and fertilizer consumption, and to account for a difference in production technology. Thank you.